Welcome to the Explainer. Let's jump right in. Today, we're zeroing in on the data behind that massive United Nations World Meteorological Organization report, which is forecasting near-record high global temperatures over the coming half-decade. We're going to look at the numbers, map out the timeline, and really understand the mechanics of what is actually happening in our atmosphere. No hyperbole here, just the facts straight from the scientific data. You've probably seen this stark headline from the UN's weather agency floating around. Global temperatures may reach near-record highs in the next 5 years. It is a super bold scientific projection. And in this explainer, we're going to break down exactly what that data tells us, and we're going to do it without drowning in impenetrable scientific jargon. We really want to understand the actual mechanics driving this claim. Here's our roadmap for today. First, the UN's climate warning. Second, the 5-year forecast. Third, what drives the heat? Fourth, why these numbers matter? And finally, looking ahead.
All right, part 1, the UN's climate warning.
So the critical window the UN report highlights spans from 2024 to 2028, just 5 years. I mean, that is a ridiculously short time frame when we're talking about massive planetary systems and projected changes of this scale. We aren't looking at some abstract projection for the end of the century. The data is pointing to immediate shifts happening in a window of time equivalent to, the time it takes to pay off a standard car loan. It is literally right around the corner. The acceleration becomes incredibly clear when you stack up our relatively stable historical temperature averages against these forecasted near-record highs. We are essentially moving from a comfortable baseline, one that human civilization has adapted to over millennia, into a highly compressed 5-year period of anticipated historical peaks. The sheer speed of this forecasted change, it's honestly just as significant as the absolute temperatures themselves. Okay, moving on to part 2, the 5-year forecast. The UN report actually maps out a trajectory over this exact 5-year window, showing how global temperatures are expected to compound. In year 1, we're starting at a baseline that is already highly elevated. Remember, 2023 was the hottest year on record. Over the next 5 years, the global mean near-surface temperature is predicted to sit somewhere between 1.1 and 1.9 degrees Celsius higher than pre-industrial times, building toward a potential near-record global peak. So it's not exactly a steady, gentle slope. It's a targeted buildup toward those forecasted highs. Which brings us to a massive number, 1.5 degrees Celsius. If you follow climate science, you absolutely know this benchmark. But check this out. The stark takeaway from the new WMO data is that there's now an 80% likelihood that global temperatures will temporarily blow past this 1.5 degree mark within this exact 5-year window. Breaching this, even temporarily, represents a huge shift in the data and serves as a major, glaring indicator of the changing state of our global climate system. Let's dive into part 3. What drives the heat? So, what is actually fueling this? Well, a big player in recent heat spikes has been El Niño. That's the natural warming of the ocean surface, mostly in the central and eastern tropical Pacific, which temporarily bumps up overall global temperatures. It's a completely natural weather pattern, right? A cycle that's been happening for thousands of years. Now, interestingly, the WMO is actually predicting a short-term cooling transition toward La Niña pretty soon. But, and this is a critical but, the underlying momentum of our climate system means these temporary natural cycles just aren't enough to offset the broader 5-year warming trend. And that brings us to the core thesis of the UN report. It's never just one thing. The upcoming heat is attributed to compounding factors. Think of it like a 1-2 punch. You have natural climate cycles interacting with the relentless, long-term accumulation of human-driven greenhouse gases in our atmosphere. It is this specific combo, short-term natural fluctuations stacked on top of an ever-rising greenhouse gas baseline, that's pushing us toward those near-record highs. It is the ultimate compounding effect. Part 4. Why these numbers matter. Here is the golden rule. Global averages dictate local extremes. A seemingly tiny bump in the global average temperature, like brushing right up against that 1.5 degree mark, doesn't mean your hometown just gets a tiny bit warmer. Because the Earth's climate is this highly interconnected puzzle, shifting the global average actually translates to massive, outsized, and highly disruptive changes in local weather patterns. A small nudge in the average means massive spikes at the extremes. So what do those local extremes actually look like? Based on the UN's report, hitting these near-record highs over the next 5 years could trigger 3 main disruptions. First, an increased frequency of extreme heat events. We're talking longer, hotter, and frankly more dangerous heat waves. Second, dramatic shifts in global rainfall patterns, which means severe droughts in some areas and intense flooding in others. And third,
All of this puts enormous stress on agriculture, our food supply, and our physical infrastructure. The bottom line here is that this global forecast has very, very tangible local consequences.
Finally, part 5, looking ahead. So, what happens next? First and foremost, the scientific community is completely mobilized. The next 5 years are going to serve as a definitive, real time testing ground to track these temperatures and validate the predictive climate models. We have the WMO's forecast in hand, and now we basically watch the actual data roll in month by month. It is absolutely crucial for observing how closely reality mirrors these projections, which in turn helps scientists fine tune their understanding of the incredibly complex interactions between natural oceanic cycles and atmospheric greenhouse gases. I want to leave you with this provocative thought to chew on. As the data plays out over the next 60 months, how will human adaptability evolve as we navigate this unprecedented temperature window? We have the forecast, we know the compounding factors, and we definitely understand the potential extremes. The true test of the next 5 years won't just be what the thermometers read, it's going to be how our global capacity to adapt is pushed to its limits. Thanks so much for joining me on this explainer. Keep your eyes on the data and keep questioning the world around you.